Hi everyone. Today I'm going to go through solving quadratic equations by using the quadratic formula. Last week we did solving quadratics by factorizing, which is one of the three methods to solving quadratic equations. And this week we're going to look at the second method using the quadratic formula. So you can see on the screen here the general form of a quadratic equation, which is ax squared plus bx plus c equals 0. Now this is what all quadratic equations will generally look like. So from last week we were doing equations that looked something similar to this, and you can see by comparing it to the general equation they pretty much generally look the same. You have an x squared term. In this case a is 2. You have an x term where our b is 4, and we have a constant at the end, so our c is 1. Now all quadratic equations follow this and look like this, but there are some times where we can't factorize the quadratic equation because we can't find two factors that will allow us to factorize. So we would use an alternative method called the quadratic formula, and that's this formula here that I'm highlighting in yellow. Now, unfortunately, you need to learn this formula. It's not given to you in the exam, and you need to learn it in order to be able to use it. And a lot of the time we only use it on a calculator paper, but you can in theory use this with any quadratic equation. If you use it on a non-calculator paper, you would have to be able to do all these calculations without a calculator. Now, the biggest giveaway to indicate that we use the quadratic formula is how the question is worded. So if we look at the first example, it says here, solve the equation x squared minus 5x plus 3 equals 0, giving your answers to two decimal places. Now, nowhere in that question does it say by using the quadratic formula, but because it ends in the sentence two decimal places, this is the biggest indicator that tells us that we should be using the quadratic formula rather than factorizing. So let's have a look at the equation itself. So you can see we've got x squared, and that's our first term, which matches with our ax squared. We got then minus 5x, which matches with our bx, and then we've got 3, which matches with our c, equal to 0. Now, just like before when we were solving quadratics, the very first step when we're factorizing was that the equation must equal 0. The same still applies with the quadratic formula, so it must equal 0. Otherwise, we can't solve the equation. So we're okay here. We've got it equal to 0, so that's our first step complete. Now, this time we're not going to factorize. This time we are going to identify our a, b, and our c. So step 2, write the values of a, b, and c. So here, a is the number that's in front of our x squared, and here we haven't got a number in front of our x squared. Now that doesn't mean a is 0. If a was 0, then we wouldn't have an x squared, because it just doesn't exist. We have an ax squared or ax squared, so that means we have 1 ax squared, so our a is equal to 1. Here our x term is negative 5, so b is negative 5, and our c is 3. So now we've identified our values a, b, and c. And then our third step is to substitute it into the quadratic formula. and calculate x. So our quadratic formula is what we've got up at the top there in yellow. X equals negative b or minus b. And then there's this symbol, plus, minus. Now, the reason there are two symbols here is because we've got to do two calculations. We add the square root of b squared minus 4ac, and then divide it by 2a. And then the second time we do it, we have to do minus b, subtract the square root of b squared minus 2ac. Now, the reason it's a positive and a negative is because when we square root a number, so for example, the square root of 9, we know is 3, but actually the square root of 9 is also negative 3, because if we do negative 3 squared, two negatives make a positive, which makes 9. So there's actually two solutions to when we square root a number. So we're actually going to end up with two answers for x. So let's do the substitution. So x equals negative b. Now, our b is already negative 5. So what's actually going to happen is we want a negative of a negative. So negative 5, which would make it positive 5. Plus or minus the square root of negative 5 squared minus 4 times 1 times 3. And all of this is divided by 2 times 1. Now, if you notice, I've put brackets around my substitutions here. It's because this is really important. If we don't put brackets in a calculator with minus 5 and just do negative 5 squared, your calculator will just square the 5 and then put the negative in front of it. So it would say negative 5 squared is negative 25, when actually negative 5 squared is at positive 25. So it's really important to be careful of how you enter that into the calculator. So we have to do this twice because we have to add the square root and subtract the square root. And there's a couple of ways that you can do this. The first method is by putting all of this into the calculator, but just doing 5 add the square root of all of this divided by 2 times 1. Write down your answer, and then do 5 subtract the square root of everything divided by 2 and write down your answer. Or you can simplify the calculation first before entering anything into the calculator. Now, I prefer the second method because if you put all of these values in the calculator, you make a mistake. It's sometimes difficult to see where that mistake is made. If you do a lot of the working out beforehand, it can simplify what you're entering into the calculator, making it easier for you. And it also makes it a little bit easier to enter it the second time instead of trying to do it twice. So I know negative 5 squared is 25. And 4 times 1 times 3 is 12. So 25 take away 12 goes in under the square root. Now, you don't have to do this all in your head. You can put it into the calculator if you want to. I also know 2 times 1 is 2, and I'm just going to put that in the denominator. And then again, I'm just going to simplify this again. 5 plus or minus the square root of 25 take away 12, which leaves me with 13 over 2. Now, when you're using the calculator, I do suggest using the fraction button. I'm not sure you can see in the video where I'm pointing. Okay, so using the fraction button would be the most useful, as that will guarantee and make sure that your fraction line, as I've written on the screen, goes all the way across the screen of your calculator. So 5, hit your fraction, 5 plus the square root of 13 over 2. So hopefully If you can see, it might be backwards. I apologize. You can see that the fraction line has gone all the way across the entire fraction, and it looks like the working out that I've put on the video screen there. It's important you do make sure the fraction goes all the way across. Otherwise, you will end up with the incorrect answer. So make sure you set that up correctly. If you don't have a scientific calculator and you just have a regular calculator, you can just do 5 plus the square root of 13, press equals, get your answer, whatever that answer might be, then divide by 2. So make sure you do press equals, because you want to divide the answer of the entire numerator of your fraction by 2, and don't just automatically. So don't do 5 add square root of 13 divide by 2 like this in your calculator, as that will only half the root 13 instead of everything, which is the numerator on the top. Now, it's an easy fix. You can either press equals or you can add brackets like I've done where I've written it on there. Okay. Now, you need to do this twice, like I said before. We've got to do the positive. So x equals 5 plus the square root of 13, all divided by 2. And then the negative, so 5 subtract the square root of 13 all over 2. And you'll end up with 2 different answers. So for the first answer, for the positive, it's going to be 4.30. And for the negative, it's going to be 0.70. Okay. It is quite a difficult process the first time that you do this, because there are quite a lot of steps and a lot of substitution, but do take your time. I do suggest simplifying it first before putting it into calculator, because it is a lot easier to put just 3 numbers in the calculator rather than 1, 2, 3, 4, 5, 6, 7 numbers into the calculator.